So good evening, good afternoon to everybody. It's my pleasure to introduce the panel on commercializing industrial decarbonization solutions. We have an all-star cast here. Actually, my name is Michael Baldea. I'm a professor here at the University of Texas at Austin in chemical engineering and in computational engineering and sciences. And I also serve as the Chief Technology Officer for EPIXC, which is the DOE institute that focuses on electrified process heating. So it's really my pleasure to be here. I want to thank the organizers for doing such a fantastic job. And we talked beforehand, as you can imagine, and we decided that each panelist would introduce themselves, and we'll go from there. So it's my pleasure to have you all here. We'll start from my left with Zach.
Awesome. Thank you all for being here today. I'm Zach Schultz, Chief of Staff at Arcadia eFuels, filling in for Amy. So you see that on the screen, clearly a difference there. But Chief of Staff at Arcadia, I graduated from McCombs here at the University of Texas, was in the tech industry and finance, most recently at Google Cloud Geographic Distribution, and joined Arcadia a year and a half ago as Chief of Staff.
Thank you for being here.
My name is Stephen Scott from Greenstar BCS. We're a small techno-economic consulting firm specializing in low-carbon fuels, carbon capture, the circular economy, looking at front-end studies, evaluation of projects. I'm based in California. I started work in the gas industry in the UK and ended up working for an American engineering firm in London, which moved me to California for 2 years. That was 18 years ago. I'm happy to be here today.
I'm Gabrielle Finger. I am also not up there. We had a bit of a shift, exciting times here. So our wonderful guests at Capsol had a business deal. So I work for Strega. I am a carbon capture project developer based out of the UK, or my company is based out of the UK. I'm based in Houston. Excited to be here. I was able to join the panels last year as well, so glad to be here to talk with you guys today.
Thank you for being here and for pinch hitting.
Sure, don't ask me tough questions and we should be fine.
I never do.
Hi, my name is Kelsey Van Hoos. I lead our hydrogen and CCS business development group at Williams. We're a natural gas infrastructure business as our base business, and I sit within our New Energy Ventures group, so we're focused on decarbonizing our assets and our customers' assets through development of CO2 pipelines and sequestration.
Glad to have you. So I'll start off with a big question. You said not tough questions, so just a big question. And so in your opinion, and you represent very diverse portfolio of technologies and industries, what do you think would be the biggest challenge for commercializing decarbonization solutions in industry? I guess, do you want to start, Kelsey?
So I think the thing that we've seen for the projects that we're looking at, it's in order to be able to get these projects off the ground, you have to have scale in order to justify the infrastructure investment. And aggregating a lot of third parties into one project is a very difficult business solution. So those that can control the entire value stream and make projects go on their own, we think will probably be like the first movers to make things successful. So, we have 2 projects that we're currently developing. We have our Echo Springs CCS project up in Wyoming. That is base loaded off of our volumes, and we are sequestering it under pore space that we own in Wyoming. And then we also have our Louisiana Energy Gateway CCS project. And again, that is based off our volumes and our emissions from our upstream production. And then I think that that's kind of what you're going to see as a first mover. If you look at a lot of the projects that are progressing here in the United States, it's those projects that people control all parts of it. And we think that's going to continue to kind of be the winner until there's some type of policy that forces some companies to make decisions, because 45Q is not enough to pay for every industrial capture project out there.
From our perspective, so being able to speak to an international angle, and I agree with everything that Kelsey said on the US side, there's going to need to be, the cost of capital is high, the infrastructure development requirements are extensive, and there isn't a regulatory stick to match to the carrot just yet. The rest of the world, however, does have some sticks in play, and so in Europe, folks are being driven to market to pull together decarbonization efforts, and so a lot of that infrastructure is a requirement, and so there just is a different drive, and I think that impacts how things are progressing and the speed at which things are progressing. And then you get a lot of creative folks out there that are looking at, voluntary carbon markets or carbon tax incentives and so on, and so I think all of that starts to play into developing that ecosystem that is going to make it much more of a global story. I think there's a lot of that nascent sort of building blocks are in play, and we're just starting to stack them all together. So, yeah.
What we're seeing is an issue with financing is just pulling the financing together, making a good business case that satisfies everybody. I mean, you mentioned 45Qs, not enough to make a project fly. Some projects are flying because there's other drivers out there, but it's we're finding getting to FID is the hard part.
Certainly. So Arcadia eFuels, we are a pure play e-fuel producer. We have 3 projects that we've announced, one in Denmark, which is our flagship project, as well as a project in the UK and a project in the Corpus Christi area in Texas. This is a very relevant question for us, and we talked about the financing, the FID side, but some of the key components that are part of the challenges that we see there is, one, the capital costs, which we touched on, and then the other side of that is the contracting when it comes to the feedstock, reliability, and cost effectiveness, and then on the offtake side as well.
So very interesting answers and very sort of broad. So internal coherence, regulatory framework, financing, and then supply chain, which kind of ties with the first point regarding having this internal coherence. So going sort of more deeply into, you all represent technology companies or technology developers to some extent. What do you think that would be the biggest technology breakthrough that would make a difference in commercialization? And that sort of ties to us being in the university and a research institute that could potentially try to address some of those questions. So I'll start with Zach.
Yep. So I think one piece when it comes to e-fuels and eSAF specifically is, and that's electro-sustainable aviation fuel, for those who are not familiar with the SAF industry. But one thing that's interesting on that front for us is electrolyzer efficiencies, and that'll come over time, which is one of the advantages to eSAF as a long-term solution. So that's something that I think we're excited to see and be a part of developing from a technology perspective and partnership. But today, we're using proven technology in an innovative way and bringing that together in a design package to get eSAF to scale today. But excited to see electrolyzer efficiency and partnerships there in the long term.
Got it.
Much along the same lines as what Zach just said is the intermittency of renewable power. If you're hooked up, particularly if you're hooked up behind the meter, even if you've got wind and solar, you're looking at best 65, 70% availability, and you will have times where it's a dead stop, and that's a killer for any chemical process. Because even if you can survive the dead stop, you're still paying for that capital and the operators, and you're not making any product. So it's a killer on the economics of the project. So reliable and cheap batteries or some other way of delivering that renewable power is key to the economics of these projects.
I mean, that's the answer for me. It all comes down to the money, right? I'm here to put a project together that's sustainable and repeatable as a third-party project developer. So the cost of capture, the cost of technology, which plays directly into what Zach and Stephen are saying is the reliability and the electrolyzer stuff, which you know better than I. If you don't have that, then your cost of capital goes up, and then your project valuation goes down. And so simple economics are the biggest element for me.
So the projects that we're looking at are really on a pre-combustion basis. So we're removing CO2 from our existing natural gas stream, which is something we do today, and the majority of that is all emitted into the atmosphere today. So we're capturing off of that. So it's not really new technology for us for the projects that we're looking at today. Now, the next step for us is really going to be post-combustion capture off of our compression, so where we're burning natural gas as a fuel source. And for us, really kind of the hindrance that we see is one, the cost, but then two, the space that's required. Yes. So typically what we're seeing from a post-combustion perspective is you're doubling the footprint of whatever generating equipment that you have on site. And not everywhere do you have that luxury of that kind of space. Mm-hmm. And so that seems to really be a hindrance for us as well when we just look at, you know, how can we put these projects in place in a way that makes sense economically, but then just from a pure engineering perspective, how do we make it work where we aren't having to, you know, level a mountain or level a giant hill or build in wetlands? Because a lot of these facilities that we've already built have been built for a very long time. And when we built them, there may not have been anything near us, but urbanization has occurred around us and we just don't have the luxury of that space. So we either have to make the option of going electric, in which case you're just shifting that to the grid, or finding a way to do post-combustion capture in the space, the limited space that we have for, and typically if you're having to get creative from an engineering perspective, your costs are just escalating,
So more compact equipment in many ways?
More compact equipment, more efficient equipment with that compactness. You know, for us, the streams that we're capturing today on the projects that we're moving forward with are 98-95% CO2. And they typically are at a higher pressure because we run our still vents at a much higher pressure. However, for post-combustion, we're looking at something that is in the 2 to 6% CO2 in the gas stream, in the exhaust stream, and that is at atmospheric pressure. So you don't want to impact the reliability of the combustion engines because that impacts the reliability of the natural gas infrastructure, which is critical infrastructure for our country. So we have to be very careful of how we install equipment as well from a reliability perspective, because we cannot impact the reliability of our ability to provide energy at a safe, reliable, low cost to the American public.
So Zach, just a follow-up question to you, but when you think of electrolyzer, you're thinking of your source of hydrogen, right? And that is your one of the biggest challenges.
Right, yeah, we have CO2 and hydrogen as feedstocks, but we also, so we produce our own green hydrogen as part of our process, so 110 tons of green hydrogen production a day. And then also kind of part of this question, the direct air capture technology and seeing that scale is something that we're also, you know, excited about, and I think that we'd love to see that be part of our long-term solution. Right now, it's not cost competitive, but we'll use biogenic CO2 as part of our solution.
So maybe to sum up some of the answers that you gave to this question, it feels like there is some uncertainty related to technology, related to reliability. What would you say are the biggest sources of uncertainty when you evaluate and execute a project? And maybe I'll start again from Kelsey.
Right now, I would say the largest place for uncertainty for us is from a permitting perspective. The regulatory environment that exists in the United States today is not necessarily conducive to building large-scale infrastructure. Even though we have had Class 6 permits have been in existence for a very long time, they still take a very long time to issue. And then building pipelines, which is kind of the second piece to connecting emitters to sequestration. I think we've seen it very much in the public sphere of the opposition that pipelines are facing, and just the ability to get permits, and that permits that are durable over the long term is in question. And so when you talk about financing or you talk about being able to move forward with a project, that risk associated with that pipeline is something that's very heavily considered when we look at things. And do we think we can build this pipeline in the time that we think we can build it? You know, we talk about our permitting costs being significantly high for some of our projects, and it's continued to go up over time, even though we've kept some of our other metrics similar or brought them down due to efficiency or scale or just expertise. But that is something that we continue to struggle with, and I think the entire industry continues to struggle with.
I think that's a very apt statement. So speaking from a global perspective again, so our Storega's companies, we have projects in 2 in Europe, 2 in the US, and 1 in the Asia Pacific region, are the 5 that are public. All of them have very different regulatory regimes that they're focused on and how they're pursuing those projects. And all of them are facing some of the similar issues, is that building out that legislative infrastructure, whether that's a permit or any of the incentive programs, whatever, that baseline paper trail needs to be in place in a way that has the warm bodies attached to it to enable them. And that is challenging on the Class 6 permits in the US. In Europe, everybody wants to push it offshore, but then you're running into transportation, not just from onshore to shore, but then offshore, you know, from the shore to the site. So now you have a dual transportation element that you have to be thinking through. And, you know, the EU is a federation essentially, but everybody wants to, maybe it doesn't want to be in my backyard. And then if you move into the Asia Pacific region, you have to think about it from a transnational boundary standpoint. So you have to have bilateral treaties in place between country A and country B that allow export of a substance from country A into country B. Who gets the credit for net zero objectives, you know, for decarbonization? So a lot of that just baseline paperwork, permitting, however you want to phrase it, all of that is a high level of uncertainty and just continues to put a little bit of a lag in the system as these projects start to come online.
Yeah, just actually following on from that transnational thing, we were working on a project in Asia Pacific, and the client was traveling very, very fast. They'd gone from concept through a complete change of technology to awarding the contract for the license in less than 6 months. So we'd gone down the road, turned them around, and then got them going down the right road, and we were into process design package in less than 6 months. The problem with that was that everything else had to go really quickly. And this was one where they had to put the CO2 on boats. Mm-hmm. So they had gone off and gone for the liquefaction package, and they'd gone off and spec'd the boats as well, and got the temperatures and pressures wrong, different. They weren't wrong in and of themselves. They were just different. And we were struggling to try and get the liquefaction package and onshore storage to match up with what the ships could handle. It was, in one sense, a good problem to have, because the project was rolling forwards really, really quickly. But we could have taken a breath and missed that step out. But you can, with the best will in the world and the best intent, still make these mistakes if you don't really have an overall plan in place before you get going.
Yeah, so certainly policy and the regulatory environments is one of the key pieces here. I think we've all kind of highlighted that. And lucky for us, we get to work across 3 different geographies trying to figure that out. But the other thing I would mention too is the predictability and forecasting of your cost from a feedstock perspective. So renewable power is one of the key components of our process, and we're working with project finance here. So how do you predict renewable power prices for the next 14 years? And how do you agree with the entire value chain on that pricing? So that's something else, and then pricing of CO2, and getting those long-term contracts for project financing.
So I've heard a lot of times predictability, anticipating, looking at cost. What do you think, so certainly this requires a lot of data, and analyzing those data to generate results is something that has been a topic of a lot of discussion in the current day and age, and people do think a lot about the use of machine learning or artificial intelligence tools to do predictions. Is that something that you've considered? Is that something that you integrate in your workflows one way or another, or plan to do so in the future? What do you think the impact of this revolution is going to be on the industry, and particularly on the commercialization of the decarbonization solutions? You want to start?
I can kick us off. Yeah, so I mean, I think it'll play a key role in how any business operates. I mean, we can utilize certain tools today that, utilize AI and ML. I think when it comes to operations, safety, diligence, R&D, it can play a key role in any of those different processes. So, I mean, it's certainly going to have a key role in how we operate going forward.
Yeah, I mean, we use AI as part of our business at the moment. What we've seen, though, is because we are at the cutting edge, is that there isn't examples for the AI to really learn from and really help us move forward. Mm-hmm. Where I see it really working is when we're replicating projects, either modules within an actual job, or just going, we've built a plant in the UK, we now need to replicate that plant in the US, but the meteorological data is different. There's different frequencies on the pumps and the compressors and stuff like that, different codes. How do we quickly take this design and change it so that it's compliant for a US operation? And I can see AI helping out quite a lot there, because that's something which is going to take time, but is manageable by a machine.
So transfer learning.
Yes.
So you guys are ops people, and I totally appreciate that. And I bet you is everybody in here an engineer? Are you in the engineering side of the universe? Raise your hands. Okay, put your hands down. Who's in like the commercial legal space, business side of things? I got you, man. That's good. Okay, so that's the world I'm in. I do negotiations. I'm a deal maker, and so what I'm thinking about when at AI is I also need standardization. Nobody wants that one-off contract. A bespoke contract that I can't repeat transaction to transaction is problematic. I mean, I want a deal that's unique to the situation, but I want some of the same boilerplate and structure and repeatability for my offtake contracts. I want to just be able to churn those out so I can just get the CO2 flow in, get the cash flowing. And so from my perspective, and part of the other piece I'm up here for is for Association of International Energy Negotiators is development of model contracts for things like CO2, for hydrogen, for renewable fuels, for nuclear, in fact, if you want to talk about that. And does AI need to have that? How does IP and AI fit together? How do you think about that if you want to build those learning machines and then you have IP connections? And so that's a piece of the world that I'm sure there are very big brains thinking about that, but we get so jazzed and excited about the operational side. I think that's a piece that we need to make sure we stay front and center of. There's also all of the contractual elements that need to be factored in, and how do you bring that to bear?
Interesting. Kelsey?
Yeah, I think when we think about AI being deployed across our asset base, in CCS in particular, I think it has a lot more to do with predictive analytics when it comes to safety as well as maintenance activities, and that's kind of where we have focused our energy.
So lots of potential uses. One last question, I think, from me before I open the floor for questions from the audience, just to keeping an eye on time. So many of you do have an international perspective, and you mentioned that the regulatory framework is vastly different, and the circumstances under which you operate or develop business are quite different around the world. do you feel that you need to invest in separate technologies for different geographies, or do you believe that some largely similar technology base would be deployable around the world under different political circumstances or different regulatory environments and so on?
So we do have a corporate venture capital group where we make investments in technology, and we have invested in companies that have an international presence. I think at the end of the day, technology is technology. It can be deployed anywhere successfully given the same atmospheric conditions. Obviously, something in the tip tops of the mountains might be different than the bottom of the sea, but we're typically talking about normal locations. I think where the differentiator you see there on some of the technologies are in some of these startups, they cannot focus on a global deployment. They can focus on being deployed in specific areas where they do business or where they have headquarters. And so I think that's kind of where you'll see differentiators when it comes from technology of why is this technology getting adopted in this country versus this country. I don't know that it's always going to be because this is the better technology in this country than this one is in this country for whatever reason. I think it's more that this is where it was developed and this is where they focused their research, doing their pilot projects, getting investment, finding strategic partners. And so that's why they've been deployed there.
But if successful, it could be deployed anywhere, right?
Yeah, but I think you still have a diminishing returns. If you're chasing everything, you will probably catch nothing. If you're chasing your strategic opportunities, you have a much better opportunity of catching those. You don't want your commercial people spread so thin that they capture nothing. So you really want to find those companies or those projects that you think are a good fit where you can be successful and you can really demonstrate that you have technology that is going to work. Because a lot of times these technologies, they've deployed it on a test or on an example project, but then the real issue is getting it to scale. Can it run on that 1 million tons or that 5 million ton scale? And so being able to get there is what a lot of these companies need to focus on. And the companies that we have seen be successful have that very strategic business plan versus there are others that are kind of chasing everything. And we're like, well, what's your plan to get to scale? And they're like, oh, well, when someone has a project to get to scale, we'll do that. And it's like, well, you need to be the one coming up with that plan in order to get those investments. And those are the types of projects that we've invested in.
I agree that it's a location parameters situation for us. I mean, we're technology agnostic. We are not a technology provider, but we keep our information base of all the various technologies that are out there and work with our customer as to what's going to work best for them, whether it's a geography element, is it a real estate piece? You know, if it's a existing facility, as Kelsey mentioned, shoehorning another piece of kit in there is difficult. And so maybe some of the new technology that's modular or stackable is a better solution for them than, say, a brand new giant amine tower. And so working with them to make sure that they understand the breadth of opportunities that are out there, where they are in the technical readiness scale. You know, maybe they're out there and they can do 100 tons a day. That doesn't move the needle when you need to capture 1.2 million tons per annum. And so it's finding those solutions that work in the regions and based on their own real estate footprint requirements.
Yeah, I mean, the footprint thing, we've seen some good projects go down simply because of the footprint of those carbon capture towers. The quench units, the blowers, they're all big pieces of equipment. And then the steam to drive it all. There's a kickoff project I was on a few years ago. The client should have known better, but when I said, where's the steam coming from, there's just a look of horror around the table, and they'd missed it. Oops. Yeah, oops. I was going to talk about blue ammonia. Blue ammonia doesn't really seem to be a thing in North America, but it certainly is a thing in the Far East. And the chances are that those projects are coming here. In fact, there's already one starting up, because whatever the level of incentives are, the cheapest, the lowest cost place to do blue ammonia is the the US Gulf Coast. The infrastructure to deliver the cheapest natural gas and sequester the CO2 is all here. And it's not quite the right physical location to export to the Far East, but trying to get stuff built on the west coast of the Americas in general is going to be nigh on impossible. So it's going to get done here. But that is a very specific, they're very interested in blue ammonia, and obviously they're very interested in low-cost blue ammonia, and it's just really an energy vector for them.
Yeah, a couple of things I would add is one thing that's important from a geography perspective that you mentioned is feedstock availability, and that's going to vary drastically. So our approach is to use commercially proven technology. So one of the reasons why that matters is because of timing, right? Like we want to decarbonize aviation soon, not go through demo, pilot, long-term roadmap. It's long enough as it is. So we're looking to decarbonize aviation sooner than later, and timing matters, geographical location matters, but yeah, commercially proven technology is what's going to get that done sooner than later. But long-term, we are technology agnostic. We want to incorporate efficiencies and new technologies into our strategy in the long term, certainly.
Got it. Well, I want to give the audience a chance to ask questions. I want to thank you for very insightful answers and certainly covering a very broad set of perspectives and industry approaches to commercialization. So I'll open up the floor for questions. And I believe a microphone will be circulating, right? Or people can come to a microphone? Okay, it's whatever works. So please, any questions from the audience? And I would say, please also state your name before you ask a question.
Thanks for the insightful talk. My name's Laura. My question, I know you said that commercially established technologies are what's going to be economical and scalable, but how do you guys keep your eye out on emerging technologies? Curious about your thoughts on like geologic hydrogen, methane pyrolysis as potentially cheap, clean ways of producing hydrogen. Long term, those can make an impact. Specifically thinking of eFuels, but also in some of the other sectors and businesses. So how do you guys keep your eye out on emerging technologies when you guys are focused on commercially established technologies?
So I'm guessing that's a question for Zach?
For all of you, but
okay.
yes, particularly interested in eFuels, but for all of you, if you have insights.
Yeah, I can kick that off. I think one of the key pieces of that puzzle is, the team. So our strategy too is in building out Arcadia, founded in 2021. But having the right team in place, we have like over 250 years of experience on the leadership team in this industry. And one of the key components of our, company is a technology center, and having that R&D strong technology base, and having the engineering behind what we do now and in the future. So constantly evaluating new technologies, working with those partners, and being able to incorporate them into our growth strategy is something that we have, even though we're just getting started, it's something that, we have as part of our strategy today, constantly evaluating and working with those, newer technologies.
So we have, like I mentioned before, we have a corporate venture capital group. So we invest in new technology. So we are consistently always looking for what's out there. We have invested in Aurora Hydrogen. They are a pyrolysis technology out of Canada. And I think for us, we've also strategically invested in some funds that invest in lots of different technologies. And so that's a way for us to continually see what's coming through. They typically look at everything, and we get to participate in those presentations. We've also done some university sponsorships. So for technology that's kind of first of its kind, we've participated in those and been judges in some of those competitions to come up with what is the next new energy technology. And so I think you have to have a very intentional view and a very intentional strategy to make sure you're staying abreast of what's going on. It can't necessarily be who's out there pitching something to you. You have to be out there looking at everything. And so that's kind of our view. When you do need something that needs to be able to be deployed at scale, there's not a lot of technologies that have been deployed at scale. So a lot of what you're doing is you're not necessarily picking the winner, but for a project, you are picking someone that you are going to have a long duration partnership with, not just in building the project, but then operating it for, in the US, probably at least 12 years for the 45Q. So I think it's a lot about not just finding the technology that works, but finding the teams that are in place around that technology that you actually think can get this done and are going to be able to continue to be good partners as you operate the asset.
We don't have any technology of our own, but we are exposed to technology by our clients. One due diligence we've just finished was looking at turning manure into green hydrogen. It was a new novel technology. We reviewed it in great detail and are following up as it moves out of the pilot scale to a demonstration scale. We're working with two different technology developers on methane pyrolysis, just as an example, and somebody else who's got 2 or 3 ideas on plastics recycling. We keep in touch with the usual suspects in the carbon capture world, looking at their new developments as they develop their designs and putting in efficiency savings or running the system at pressure. And sometimes we look at it and they've missed something. It just isn't going to work. Or because they've taken the top of the stripper column off to save money, the water is condensing in the CO2 compressor, which I don't think that's going to be good for it. But we are constantly out there looking at new technologies, and yes, don't just wait for stuff to be brought to you, because that won't necessarily be the right stuff. You've got to be out there and active. CO2 electrolysis, no reverse water gas shift, and lower electron potential. So, but is it ready at scale?
Right.
No.
So prior to Strega, I worked for Chevron, and Chevron has the Chevron Technology Ventures, and it's I don't remember how many billions of dollars of an investment fund that it does just for, exactly as Kelsey said, pulling together and deploying capital into some of these new projects, infusing them with enough capital to take them from demo to pilot or pilot, whatever. The intention is always, as Kelsey said, is to put it to scalability. And how can it be scalable and rapid deployment for Chevron's purposes back in the day? But it benefits all of us because, the companies from a carbon capture standpoint, since that's what I work, they need that infusion of capital, and they need that built-in customer that's going to then utilize them and put it on a demo plant in Bakersfield, California, or wherever it is, to take it to that next level. And so I think you're going to end up, a lot of the big oil is going to be the folks that are going to be interested in using this and taking it from an industry standpoint, an energy industry standpoint, and figuring out how you can decarbonize, lower the carbon intensity, find different ways to continue to diversify and control that market. And so those big names are going to be your principal investors in a lot of these projects.
Other questions from the audience? This is the end of the day. Anyone else? One last chance. We got time for one last question.
Well, I guess that concludes today. So just so everyone knows, you're welcome to come and get a drink as long as you are over the age of 21. We are also having a student club mashup as well. So whether you're a professional or you are a student, feel free to mix and mingle. And thank you for joining us today.
Give the panelists a round of applause.